Hello and welcome again to CHeM in 3. Today we develop on two concepts: assigning oxidation numbers and identifying what is oxidized and what is reduced in an equation based on change in oxidation number. Building upon these two concepts, we seek to develop your competency in applying them to balance redox reactions using the half equation method. First, I'm going to walk you through one example, and then you can solve another one on your own. Let's move in and take a closer look. This is the equation that must be balanced. Out of this equation, you need to first take out the two half equations. So iron with oxidation state positive 2, and it's important to note that here this is the charge and not the oxidation state. The oxidation state should be written as positive 2 and the charge is written as 2 positive. We see that the oxidation state changes from positive 2 to positive 3. Oxidation is a loss of electrons and reduction is a gain. For iron to go from positive 2 oxidation state to positive 3 oxidation state, it would have to lose an electron. It is oxidized. Moving to manganese, you should note from your earlier work on calculating oxidation numbers that manganese has an oxidation state of positive 7, and this is changing to positive 2. For this to happen, 5 electrons need to be added or gained by Mn7 positive. As it does this, manganese goes from oxidation number positive 7 to oxidation number positive 2. And these are the two half equations. Now if we combined these two half equations, notice that I added a 5 to the Fe2 positive because each Fe2 positive loses 1 electron and manganese needs 5 electrons. So we'll need 5 of these to satisfy 1 of these. So putting a 5 in front of Fe2 positive, we rewrite the equation and we put a 5 in front of Fe3 positive. So once we've recombined these two half equations, after you've used the half equation method to see what's oxidized, what's reduced, and how many electrons are needed and how many electrons must be lost, we recombine them like this. The charges don't balance, and also there's oxygen on this side and there's no oxygen on this side. Counting up the charges, we can see that 5 multiplied by 2 is 10 positives minus 1, 9 positive, and on this side 5 multiplied by 3, 15, plus 2, 17 positives. So to address this balance, we add 8 hydrogens on this side. What that symbolizes is that this redox process is happening in an acidic medium, an acid solution, and that's why we actually have to add these free hydrogens. And to balance everything off on this side, 4 H2Os are added. That's going to give 4 times 2, 8 to balance the 8 hydrogens. And notice the oxygens would also balance, and you would have your balanced redox reaction. This particular reaction being an acid solution because we had to add 8H+, but we began first by deriving the two half equations and then seeing that manganese, which is gaining electrons and being reduced, needs to get 5 electrons, and iron, which is losing electrons and being oxidized, is only losing 1 electron. So based on that relationship, we would have to multiply this by 5 to satisfy this. And in this case, the ratio is 1 to 5. But sometimes it might be 2 to 3, and you'd have to choose the right numbers to multiply in some cases both equations by a coefficient so that when you do that, things would balance. In this next example, both equations need to be multiplied by a factor so that you can then end up with a balanced equation. So stop here now and use the steps from the example to try to solve this question. When you're done solving it, advance the video and look at the final answer. And if you have any questions or comments, please write them in the comments section below this video on YouTube. Now here's the answer. First of all, writing the two half equations. Then, in this case, multiplying this one by 3 to get 15 electrons and multiplying this one by 5 to get 15 electrons. Once you have that, then you can recombine both equations, add 6 hydrogens to this side to balance the charge, and add 3 H2O to this side to balance the hydrogens. Notice again that the oxygens would automatically balance. 3 O's plus 4 times 3 is 15 O's, and 5 times 3, 15 O's on this side. Your final answer is this.